All right, class. Right now, I'd like to talk to you guys about Nist. And Nist stands for the National Institute of Standards and Technology. This is a reference on constants, unity, and uncertainty. The main thing that I want to focus on will be units. And I want you to understand that uncertainty will always accompany a measurement. Okay? So let's just go into the introduction real quick here. It says this is a brief summary of the SI, the modern metric system of measurement. Long, the language universally used in science. The SI has become the dominant language of international commerce and trade. So this should really give you a good idea of what we're talking about. Some useful definitions are down here, and let's just go over them real quick. A quantity in the general sense is a property ascribed to phenomena, bodies, or substances that can be quantified for or assigned to a particular phenomenon, body, or substance. Examples are mass and electric charge. Uh, a quantity in the particular sense, a quantifiable or assignable property ascribed to a particular phenomena, body, or substance. Examples are mass of the moon, the electric charge of a proton. Okay. Physical quantity is a quantity that can be used in the mathematical equations of science and technology. All right. A unit is a particular physical quantity defined and adopted by convention, with which other particular quantities of the same kind are compared to express their value. So that's very important. And then the last one, the value of a physical quantity is the quantitative expression of a particular physical quantity as the product of a number and a unit. The number being its numerical value. Thus, the numerical value of a particular physical quantity depends on the unit in which it is expressed. All right, so we can go into an example there, but I just really wanted to bring those things about to try to make it a bit clearer. You guys can go ahead and read over this as far as when we start talking about units, how they connect to physical quantities. Okay, so I'm just going to go ahead and go to the next page, and I want you guys to see this table here. This table is the SI base units table. And so we only have 1, 2, 3, 4, 5, 6, 7 base units. All of our other units, our derived units, will be based on these 7 units. So the better we can actually establish a meter, a kilogram, a second, an ampere, a Kelvin, a mole, and a candela, the better we can do that, the better all of our other units will be. Okay, all of our derived units. All right, so that's really part of the goal of NIST. And so if we go down, you'll see that you have derived units like area. So the square meter is just a meter squared. Volume is meters cubed. And then we have speed and acceleration, meters divided by a second. And if you go back up, you'll see that we have meters and we have seconds. It's just a ratio when we start talking about the speed or velocity. We also have acceleration. It's meters per second, second. How you doing? It's meters per second, second. And so these are some of the things that we can these are some of the things that we can derive from our base units. And you see this everywhere. And make sure you guys look at the YouTube video as to why the National Institute of Standards and Technology actually exists, why it was established, and how it benefits us in science and technology, biotechnology, all kinds of things. Okay. And so here's some more derived units. If we just keep going, you'll see that you have many. And there's a link there as well. Now, remember at the beginning, we talked about prefixes, and I didn't specify it. I didn't call them SI prefixes. I'll just go ahead and call them that from now on. But you have the iota, the zeta, exa, peta, tera, giga, and mega, kilo. And so we use these in front of our units. So if we wanted to describe a bit, we can call it a gigabit. Or if we want to describe frequency, we can call it megahertz. If you think about your radio station, it's 101.1 megahertz. If you want to describe um, a micrometer or a micron. A micron is going to use this little funny looking symbol here, and you're going to put a meter right next to it. Okay, so we use these, and we've talked about these before. So you guys go and check it out. It's pretty standard, and that's all I'll talk about with this video. Just wanted to bring this into play when it comes to the class.